This will be for the con exercise, remainder theorem. All right, some notes before we begin. We're going to let P of x be a polynomial. And to get the remainder when dividing P of x by x minus c, you plug in x equals c. All right, so in other words, if this is minus c, you're going to plug in x equals positive c into the polynomial P of x. Okay, and to get the remainder when dividing P of x by x plus c, you're going to plug in x equals negative c. Okay, so in other words, you're just changing the sign on this and plugging it into P of x. So just as a quick example, if you take the polynomial P of x and you divide by x minus 4, you're going to plug in positive 4 in place of x. So the remainder is going to equal P of 4. In other words, whatever you get when you plug in positive 4 in place of x. So notice this is x minus 4, but we're plugging in positive 4. So say you have a polynomial P of x and you're dividing by x plus 7. In order to get the remainder, you're going to plug in x equals negative 7. All right, so for the polynomial function, you're plugging in negative 7 in place of x. Once again, whatever you're dividing by, you're changing the sign on the constant term and plugging it in for x. And that will give you the remainder. All right, it says P of x is a polynomial. All right, P of x divided by x plus 7 has a remainder of 5. Okay, so in that case, since this is x plus 7, we're plugging in x equals negative 7. And when we plug in negative 7, we get a remainder of 5. So in other words, when you plug in negative 7 here, you get 5. So P of x, we're plugging in negative 7 in place of x. That means P of negative 7 is going to equal 5. All right. And for the next scenario here, let me separate all these to make it more clear. Okay, P of x divided by x plus 3 has a remainder of negative 4. Since we're dividing by x plus 3, we're going to plug in x equals negative 3. All right, so plug in x equals negative 3. And when we do that, we get negative 4. So if you evaluate P, at x equals negative 3, you get negative 4. All right, here P of x is divided by x minus 3. So that means we're going to plug in x equals positive 3. Okay, and when we do that, we get a remainder of 6. So P of 3 equals 6. Okay, this just means we're plugging in x equals 3 in the P function. And we get 6. All right, see if you can figure out the last one. Okay, we're dividing by x minus 7. That means we plug in x equals 7. X equals positive 7. All right, you're always changing the sign and then plugging it in. So when we do that, we get a remainder of 9. So P of 7 is going to equal 9. Okay, so all of these are useful, or at least some of them are useful for our multiple choices, which we're going to get to. All right, let's see the choices. Find the following values of P of x. So they want to know P of negative 3. which we found already. P of negative 3 is negative 4, so just click in the box and type that. And they want to know P of positive 7. We found that too. P of positive 7 is 9. Okay, so that's it. Negative 4 and positive 9. All right, P of x is this function here where k is an unknown integer. P of x divided by x minus 1 has a remainder of 0. What is the value of k? All right, so based on this second sentence here, P of x divided by x minus 1 has a remainder of 0. That means since we're dividing by x minus 1, we're going to plug in x equals positive 1. And it has a remainder of 0. So when you plug in x equals positive 1, you get 0. All right, in other words, when you plug in 1 in here, P of 1 is going to equal 0. All right, so let's do that. Okay, we said P of positive 1 equals 0. So we're going to plug in x equals 1 in each one of these and set it equal to 0. All right, so when we do P of 1, that's going to be 1 to the 4th minus 2 times 1 to the 3rd plus k times 1 minus 4. And when you plug in 1, we said that you get 0. So this whole thing is going to equal 0. Okay, now let's see. 1 to the 4th, 1 multiplied 4 times is just 1. 1 multiplied 3 times is just 1 times negative 2. That's going to be negative 2. Plus k times 1, that's just k. And then minus 4. And that equals 0. Okay, 1 minus 2 is negative 1. Minus 4 is negative 5. Okay, so 1 minus 2 is negative 1. Minus 4, it's negative 5. And we still have plus k. And that equals 0. So negative 5 plus what equals 0? Well, that's just k. That's just 5. So k equals 5. All right, you just add 5 to both sides. If you want to see me do that, we have a negative 5 here. We're just going to do plus 5 on both sides. 5 minus 5 cancels, and k is going to be positive 5. So that's it. All right, one more. It says the polynomial p is graphed. What is the remainder when P of x is divided by x minus 3? Okay, remember when you divide by x minus 3, we're going to plug in x equals positive 3. Okay, now we don't have a function P of x to plug it in, but we have the graph. So all we have to do is look on the graph at x equals 3 and see what the y coordinate is. All right, so here is our graph. All right, we're plugging in x equals 3. This is the x-axis. We go to x equals 3, and we want to go to the graph at x equals 3. So this here is x equals 3. That's right here. And the y value at x equals 3 is going to be positive 1. So at x equals 3, y equals 1. Okay, so the remainder is just 1. Okay, that's how the theorem works. All right, so when you divide by x minus 3, the remainder is just 1. All right, I'll just do one more real quick. What is the remainder when p of x is divided by x minus 2? When dividing by x minus 2, you're plugging in positive 2. So just plug in positive 2 in place of x, and whatever you get is going to be your remainder.